Number 82. Explain why the number of molecules are not identical in the left and right-hand bulbs shown in the center illustration of figure 9.27. Okay, so I pulled up that figure. This is figure 9.27, and it basically is flowing from left to right. So basically in this example, you have two different gases. You have hydrogen gas, H2, and you have oxygen gas, O2. The hydrogen gases are white balls, and the oxygen gases are these like red balls. And the stopcock is closed, meaning that this little gadget inside is closed. So that means no hydrogen can enter the O2 chamber, and no oxygen can enter the hydrogen chamber. Now, what happens is the stopcock now opens, and now passage is allowed through. Hydrogen is allowed to go into this part, and oxygen is allowed to travel this way. What was that? And then, after some time, seems like they finally equal out, and the stopcock is still open, so they are free to travel, right? Now, why are the number of molecules not identical on the left and the right-hand side of only this picture, right, this illustration? Well, this has to do with the molar mass of the gases. We have H2 and we have O2. H2's molar mass, if we look that up on the periodic table, I got 2 hydrogens, so 2 times 1.008 would be 2.016, and that's grams per mole. And O2 is basically 36, right? 36.00 grams per mole. Now, the rule of thumb is that the gas that has a higher molar mass travels the slowest, right? So in order to travel as a fast gas, you cannot have a high mass. The lower the mass, so maybe I'll write that down and we'll say the lower the mass of the gas, that means the higher the rate. So that's a principle in chemistry. So the lower the mass of the gas, the higher the rate, and the faster it's going to travel. So let's just look at that, the molar masses of H2 and O2. Well, H2 definitely has a lower molar mass than O2, right? So if we put that idea to mind, if this has a lower molar mass, and I'll just say that that's mm, the rate of, traveling is going to be higher. In this case, the molar mass is higher, so the rate in which it travels is going to be very slow. So once that stopcock opens, notice which side has the more coloring. The white is on the left side, and the red is on the right side. But as you see, there was only 4 oxygen molecules that were able to go from the right to the left because it weighs more. It has a larger molar mass. But look at all these white dots representing hydrogen. I can count more than 4, right? And if it has a lower molar mass, the rate is higher. So that's why they're not equal, because the lower molar mass, the higher it's going to race right out. And that's why. All right? So hopefully that makes sense. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out. And I will see you all in later lessons. Have an awesome day. Bye-bye.